Welcome back, scholars, to the back end of our journey through statistics, or at least the first half of our journey. So, up until this point in time, we spent a significant amount of time discussing the standard normal distribution, what statistics actually is, what goes into creating a good study. So, knowing that information, we now need to decide whether or not certain events are fair using statistical data to back our initial assumptions. We can't simply rely on our own emotion to dictate whether or not something is deemed valid or fair, especially as you get set to become an adult and join us in the real world. So we're going to learn to comprehend that probabilities from simulations may differ from expected probabilities, so I can use data to critique mathematical claims based on a model in different cases. I'll know I've got it when I can use mathematical evidence to find the difference between when outcomes are unfair or due to random chance. So here we have Lynn, Kieran, and Diego shooting 100 free throws for practice. Based on their shooting in the past, Lynn thinks they are all of similar ability and estimates that they each have 60% chance of making each shot. They each shoot their shots. No pun intended. From the results stated here, do you agree with Lynn's estimate for the chance of each person making each shot? Explain your reasoning. Sometimes, especially in life, there is no clear-cut, textbook-defined answer. Oftentimes, we define an answer to be sufficient or valid based on the evidence that you use to validate your claims. So, in this instance, and subsequently those ahead of us, please ensure that you're trying to tie in the mathematical behavior as noted here and your initial assumption. All right. What is the probability that you will flip heads or land heads when flipping a coin? And estimate the number of heads you will get when you flip a coin 20 times. Share those two values with your classmates because you are going to select this hyperlink, which will take you to a separate page. If you scroll down to halfway on the page, you will see a applet where you can electronically flip a coin 20 times and record the number of heads you obtain. You're going to repeat that process 4 more times. So in total, you will have flipped that coin 100 times, and it will keep track of the number of heads and the number of flips you've done. Enter that data into the table. Here is a dot plot based on the number of heads in 20 flips that I was able to create for a particular class. What is the least number of heads flipped by the class in 20 flips? What is the greatest number of heads flipped by the class in 20 flips? Remember, each dot designates a value that a particular member of the class had obtained, with dots stacked above each other indicating multiple students having that number for heads. Based on the class dot plot, describe a range of values that represent a reasonable number of heads to flip when flipping 20 times. Disclaimer, it will not be every value between 4 and 16, because if you take a look at our dot plot, you can sort of draw a bell-shaped distribution, which should allow you to determine a range of values that is reasonable. Priya flips her coin 20 times and it lands showing heads twice. Is this possible for this to happen with a fair coin? Fair meaning heads and tails, or not fair meaning double heads, double tails. So if you say yes or if you say no, based on the class distribution, so from the previous slide, should she be suspicious of this being an unfair coin? Remember, yes or no is not sufficient enough here. We need to say yes because yada yada yada, or no because this X, Y, and Z. And then let's project, right? Let's say we did this with 1,000 people flipping a coin 20 times. How might that change our prediction from the range for this class's data? Which brings us to our final activity, which is where we are going to focus on this concept of fairness. So I would pause the video now so you could read through these 2 paragraphs of text that are detailing a principal selecting 8 students from the school to interview. Do you think the principal could have chosen this group of students at random like she promised? Once again, we have another dot plot that was created that shows the number of students chosen from the graduating class by all the students in our class. Based on the dot plot, do we think it's reasonable that the principal selected the students for the interview at random, or still chose 5 of the 8 students who are in the graduating class? Explain your reasoning. And then in this final slide, I'd like for you to share with your peers your initial thoughts about how we can fit a normal curve to this idea of fairness. And then if you've ever experienced a situation that seemed unfair, but might have possibly due to random chance, what are other mathematical things you could do to help decide whether it was due to random chance or deliberately unfair? As always, make sure you read through the Lesson 8 summary. It is very well written and should help clear up any misconceptions before pausing, where we can tease apart these concepts together in class.